Welcome to the Beyond 3D podcast, where we explore all things 3D and the important role that 3D data plays throughout the manufacturing process, driving decisions throughout a product's lifecycle. Here, we talk with industry analysts, business owners, developers, and industry influencers, and hear real stories that you can relate to and learn from, and know which trends and technologies apply to your business. So join us as we go beyond 3D. Welcome, everyone, to another episode of the Beyond 3D podcast. My name is Angela Simoes, and I am here with a longtime colleague and friend, Pete Kelsey. How are you, Pete?
I'm doing really well. How are you?
I'm doing all right, thank you. Pete is the owner of VCTO Labs, and our initial meeting, we started working together at Autodesk, so we go back a long time. So really excited to talk to you today. And from the TechSoft side, we have Jonathan Giroir, who is our technical evangelist, and here to help drive the conversation. So to kick things off,
Hey there.
So to kick things off, Pete, I have often said that you just have one of the coolest jobs in the world. So why don't you give our listeners a little bit of background on what that is and kind of how you got to where you're what you're doing today.
I'm really stubborn. That's how. Let's see. The short story is I sort of stumbled into civil engineering, 25, almost 30 years ago, and sort of kicked my way into that space after learning this new thing called AutoCAD. And years and years go by, and next thing I know, after having a successful run at a services company where we would train people on how to use the civil engineering software at the time. It was, my gosh, depending how far you go back, DCA, Sofdesk, Land Desktop, and then Civil 3D. I took a job at Autodesk, and like Jonathan, on my business card, it said technical evangelist. So I was technical evangelist for the civil products for Autodesk for a couple of years until, it was in 2008 when, the global economy melted down. And anyway, I took a role in sales for a while at Autodesk. And then again, just being stubborn and getting really interested in trying to find, a new way to not sell, but more inspire, folks to action, got involved with special projects, really high visibility projects where, we could engage with, at the time, some of Autodesk's largest customers to do something really interesting. And the result being, holy cow, how did that happen? We had no idea. The relationship changes. It's no longer sales. It's now a business partnership. Was wildly successful. Short story. And I became addicted to that, and have been ever since. And was so inspired by that then that when, Autodesk went down a different path, I'm like, I have to do this anyway. So I stepped out of Autodesk and started doing it on my own. So, and in the middle of that, if there's a common denominator in terms of technology, it's been with me for, over 15 years now, it's reality capture. I mean, it just grabbed me and has not let go because of how it can touch every industry, everyone. I mean, it was my North Star, and I didn't even know it.
So that's what we're talking about today, right, Pete, is reality capture. So that's the collection of point clouds with some sort of technology, many times like a laser scanning device. And we've seen that in the industry for decades now, but it continues to, the technology and the tools we have to deal with that data, the hardware continues to change. TechSoft, we deal with that from a software standpoint, processing the point clouds, displaying the point clouds, denoising the point clouds. But we're real curious. You've been doing this for a while, but I've kind of been out of touch with some of those technology advancements in more recent years. What are some of the exciting things you've seen in the last couple of years? We can go back maybe even 5 or 10 years, but what are some of the big advances in point cloud acquisition and processing that you've seen, so we can kind of bring our listeners up to date as well?
Sure. I guess in no particular order, two things come to mind. One is the speed of capture, meaning your time in the field has gone from extraordinary to not so much. I mean, there's been a huge advances in the time to do quality capture. And that's regardless of technology, whether it's LiDAR, photogrammetry, pick your sensor. So, and that, of course, speaks to everyone who does what I do, because, of course, time is money and efficiency and et cetera, et cetera. So the speed with which we can capture quality data continues to improve, actually. But I mean, night and day from when I first started this back in 2006. The other thing, I guess, on the processing side, I mean, the elephant in the room to me is the cloud, or, infinite computing, because back in the day, you were completely dependent on your local hardware solution, right? Your laptop or your workstation. And it was never enough, because, if we looked at a pie chart or a graph of, the size of the data sets on the capture side, it's been going up. It's always going to go up. It's never going to go down. So the cloud changed everything, meaning, although sort of ironically, the shift from where all the frustration and bad language and, of being in this space where it once was on the computing side is now it's really on the Wi-Fi side. Because, if you spend a lot of time in the field like I do, and you're in a hotel and maybe the Wi-Fi isn't that great, and you're trying to push 50 gigs up at like dial-up speeds, that, it's like, I remember these creative profanity strings, but it used to be done because of lack of, computing power, whereas now it's Wi-Fi. So, yeah, I think those are the two biggest things for me, is time to capture, and then the cloud just shifting, the heavy lifting, all the post-processing to, massive server farms, which is great, because now size does not matter in terms of the data set, which is so, what's the right word? Enlightening, or it sort of opens up for someone like me. The answer was like, well, how much data are we talking about? How big's the building? How big's the area? That doesn't really matter anymore. It's, that part is, we can do that.
Yeah, so the arms race continues, and we see that across all the industries that we provide technology to. So it's not just reality capture, but as computing power continues to improve, that's great. Moore's law continues to continue, but the size of our data just also compounds at the same exact rate. So we still have the challenges that we had long ago, but that throughput, that's really interesting. Now we're not limited to our processing power on our machine, but just the massive amount of data that you're pushing to get to processes, that is critical. Hopefully with 5G, that seems to be a new technology that a lot of people are leveraging that allows greater throughput and connectivity when available. When you talk about the workflows, so we talked about some of the advances in more data processing on the cloud, and actually we see that too, is a lot of 3D engineering technology all moving to the cloud. We're all connected with our technology no matter what, but it's this industry is now especially being accelerated by the work from home life of COVID. So much technology in 3D engineering is going to the cloud. So we see that migration as well, and are trying to support that. But now that we have this data and it's something that we're used to working with, I'm kind of curious about the different workflows that you're able to unlock. Another word that we've heard quite a bit is that of the digital twin. So a digital fingerprint or footprint or model of the built world, and being able to, as the built world changes, that digital model is able to be updated real time. How is reality capture supporting this idea of a digital thread or a digital twin?
Oh, it's at the core of it. It's you can't have one without the other. It's and I realize I'm preaching to the choir, but it's how I look at capture is this inverted triangle, meaning everything starts at the bottom in terms of workflow with capture. Everything. So there would be no digital twin capability without reality capture. And oh gosh, I've got so many things in my head having to do with this. One random thought is, one of the first questions I also always ask a client is, look, tell me about your digital assets. And, and this is nothing against an owner operator, but it's still sort of new enough that, I would say maybe half would say digital what? What exactly? What are we talking about? Well, what digital data, what digital assets do you have of your stuff, your facilities, your infrastructure, whatever it is? And that opens up the possibility of everything else. So the other sort of random thought specific to digital twin is, to me, there's a component of this which is like sort of deja vu all over again. Like I went through when BIM was a new acronym, a new thing, right? And people are still arguing over what BIM is, what it means. And I think the digital twin thing is going through this same thing. To me, I maybe perhaps I oversimplify, but to me, it's just a collection of data. And to your point, Jonathan, if your infrastructure, your asset, your building, whatever it is dynamic in its nature, meaning it's changing. There are improvements, there are problems, there are whatever it is. If it is a dynamic environment, you have no choice but to get on the reality capture train, or you're going to get run over by it. I mean, literally, it's that ship sailed years ago. So yeah, digital assets, reality capture. There are no digital twins without those. So for those who are already on that train, power to you. For those who aren't, I would hustle. I would start paying attention, because there's just no other way to manage an asset efficiently.
Yeah. So I'm thinking about different use cases. You talk about retrofitting and renovating. So taking a point cloud of as built, maybe when there aren't design documents or a digital asset to represent that. Both in building and construction, that's a big space where this is being used. I think about civil engineering, so do a flyover of an intersection that needs to be changed in one way. Also, being able to capture, let's say, historic sites as well. But I'm curious, like, having this technology, have you seen it being applied in very unique ways, maybe you hadn't anticipated, or others that you'd like to share? Some unanticipated opportunities.
Yeah, I sure have. I think it's. I think when creative folks, when our last thing we were just talking about, digital assets, digital twin, when that sort of registers with a creative type of personality. In my case, to your point, where was I sort of surprised by that? Entertainment, right? Whether it's television, movies, sports, I mean, whatever, to have a digital asset a digital twin, a digital mock-up of whatever, the golf course, uh, some fabulous site, maybe Petra in Jordan, right? Where a million movies have been filmed. Well, why go to the expense of going to Petra when you could just scan it and green screen the entire scene? So yeah, entertainment surprised me. I can remember a few years ago bumping into something with the PGA, professional golfers, about virtualizing golf courses and having putting the golf course on the smartphone of all the professionals. Talk about making a golfer sort of invincible, right? To have the topography, maybe even AI to figure out where the ball's going to go. I mean, a great surprise. And for me, I'm a sparkly object guy. I went way down that rabbit hole quickly because it was so interesting. There's all kinds of examples like that. I mean, I've done some interesting things with the military, the old war movie thing when they're, scenario planning on the sand tables. There's no sand tables anymore. It's all augmented reality, and you don't even have to physically be in the room. And what's at the base of that? What makes that possible? Capture.
Yeah, bringing it back to engineering, I saw an interesting application. We have a partner using the Texoft 3D Hoops technology called Salmon IS in Korea. Korea is a real hub for shipbuilding. And when they build massive ships, they're built in these blocks, and they scan these blocks because, unlike a car where the tolerance between your parts might be in the fractions of a millimeter, the tolerance between these large blocks that then get welded together could be in inches or more, which it would be out of tolerance, right? And so they got to bring these together, weld them together, affix them to one another. So they'll scan them prior to make sure during the manufacturing process, when they finally assemble the ship, it's actually going to fit together. So that saves a ton of time and waste using, again, they laser scan it and then do this digital overlay. You mentioned AI, and that obviously is touching so many industries right now. And in 3D engineering, we're trying to figure out, where does this sit? Are you seeing opportunities or uses for AI within your different workflows?
Absolutely. The big one to me is always change detection. Probably on equal footing with feature extraction, edge detection. Folks have been working on that for decades. And for AI, could AI potentially be a solution to that problem? Absolutely. Go find everything that looks like a stop sign or a fire extinguisher or whatever. Absolutely. That, of course, removes some of the most mundane, horrific CAD work there's ever been, right? What else? Change detection, obviously a big one, again, in a dynamic environment. You could use the example you just mentioned, shipbuilding, right? But it could, any construction environment, actually, is this built to spec? Are there problems that if aren't identified prior to assembly or construction would be catastrophic in terms of schedule and budget? AI is perfectly suited for that. Look, here's my data. Just, look at it. Tell me what you see.
Yeah, I could see, especially if you do have the as built, right? So your point cloud as built compared to your as designed. So that's original CAD drawings, being able to more intelligently look at, all right, is that ductwork actually where it's supposed to be? Is that piping actually where it's supposed to be? And be able to automate that could be quite helpful.
Yeah. Well, it's anybody in our space knows that the contractors always win, right? There's as designed, there's as built. Well, and I guess this is a fine point.
Mhm.
To me, what we're touching on here is as constructed.
Right.
Is it plumb? Is it level? Is it per the plan? Is it per design? Maybe the contractor had a bad hangover that day. You never know. So that is the other reason why capture is so important, because it is reality capture. It captures what's there as it really is to a high degree of accuracy.
Yeah. So kind of bring that back, close the loop on the process.
Yep.
Great. Our audience primarily is 3D engineering software companies. So people, developers, VP of engineering, they're listening to this, trying to figure out, what are we going to be doing? What are the challenges? So I'm really curious. You have an audience here. What are the big problems you're wrestling with right now, especially when it comes to the software side of things? What are the challenges that if you had a wish list that you could go to these companies and say, hey, I need a tool to do this, this, and this? What are some of those things you really wish you had the ability to do?
Oh, I know just what it is. And, damn the torpedoes. I don't care if this is controversial or not. For many years now, I have been wishing, wondering, contemplating the scan to BIM thing, right? In that process, no matter what you do, you're going to lose accuracy from going from a point cloud to a BIM model or CAD, call it whatever, to vector-based technology, right? That makes me crazy, because the last thing I want to do is lose fidelity, right? So to your question, the thing that's, but I am going to say it out loud. Could we just skip the whole CAD part? There must be a developer out there, some really creative, innovative person who has either had this thought and is working on it, or would you please figure it out? All good things to CAD and BIM, but that technology is 40 years old. It's actually more than 40 years old. Vector-based technology, lines, arcs, circles, text. Really? Why would somebody who does what I do want to dumb down a point cloud? That seems counterintuitive to the end result that everybody wants, which is a very accurate digital twin. So I hope I'm not making enemies, but that to me has been the elephant in the room for a long, long time. And, I just wonder, there's got to be somebody thinking about it, some kind of a paradigm shift, like I'm struggling to describe, where that part could go away. Hey, we're going to get you to where you want to be, a plan set, a model, whatever it is, without losing any of that fidelity that is inherent to reality capture.
Yeah, just for clarity, that's fantastic. So you say not going to lines and arcs. Are you saying going to a planar surface, like a solid, or just keeping it in the point cloud form where that becomes the center of truth? I'm really curious.
This to me is where, folks a whole lot younger than I am, because I got a lot more years in back of me than I do in front of me in this industry. But I wish I had the answer, but I know that there are young creative folks out there who maybe right now just had a light go on and go, ooh, I got an idea. So yeah, is it solids? Is it meshes? Native point cloud? I wish I knew. Right? I don't, but that's the fun part. Hanging out with creatives and having this kind of, okay, maybe it's controversial, and I cut my teeth on AutoCAD and went through 2D to 3D and BIM, and I wouldn't be here without all of that. But to ask that sort of tough question is like, if that's what's holding this back, vector-based technology, can we please move on?
Yeah.
controversial or not.
Well, you know what? No, you heard it. You heard it here. No, that's fantastic, Pete. I'm glad you're thinking that way. And in I there is work being done in this space. I know that, and it's coming from an interesting area. It's coming from 3D printing because that's
Ooh,
also like 3D. So the idea of a voxel, so it's a 3D pixel
yep.
instead of a surface, is one way in which 3D printing is starting to think about their data. And they're having the same pain where like they have to go to slices that are geometry, that are lines and arcs, to then print. But why can't we keep it in this kind of voxel space, this 3D pixel space, and create tools there? So there's a whole discipline of implicit modeling, which is like it's either solid or it's not. I can see also what you're talking about, like a statistical layer on top of things. Like here's the
Oh,
surface, but it really, it can be between here and there, because even the point cloud is not the truth. Like there's still some variance in the point cloud or some noise in the acquisition of that. So
oh gosh. Yes. And to not to pig pile on this, but if there's another step that, we've gone through on the BIM side, is whatever the end result is, voxels, meshes, whatever it is, can we please also make it smart, right? The GIS people have known this forever. Make whatever it is, make it, what's the word? Attributes, right? I want to be able to show me all the doorknobs or the electrical outlets by this manufacturer,
right.
by excuse me, all that stuff. You guys are getting my blood up. Um, but because we went through this with BIM, and we're seeing this in the last 5 years with CAD and GIS, finally becoming, intermingled. The GIS people have been, rolling their eyes for 30 years going, it's about time you started thinking about data and intelligent models. So if whatever that next phase is that we're sort of daydreaming about, whoever has an idea to work on this, make it smart at the same time. Don't make that a third step. We went
Right.
through this before. Could we skip that intermediate step and to make these beautiful models, but also make them smart?
Yeah, so bringing that metadata in. Yeah, that's great.
Yeah.
Well, we'll let the engineers kind of work on that. We're the people who can dig deep into some of that technology, but thanks for sharing that. Let's bring it back down to earth just a little bit and talk about where you see the industry going right now. So where do you see improvements happening in the next couple of years when it comes to reality capture? What's coming?
I think it's more on what we've already talked about, which is speed to capture,
Okay.
getting in and out of the field quickly. I think it is, the classic thing with all technology is you'll see the technology footprint getting smaller and smaller. Like, great example, that's LiDAR on my iPhone.
Mm-hmm.
That touches on reality capture becoming, is it ubiquitous? Is that the
Mm-hmm.
right word? Yeah, everywhere. I mean, becoming available to everyone. So, and what better way to digitize everything than to crowdsource it? So that to me is the genius behind this little thing. What else? On the processing side, I think we've touched on that too. AI, absolutely. Um, and then beyond that, hopes and dreams about hopefully there's a better end solution than, vector-based deliverables. There has to be. There has to be.
Yeah, yeah, good. Yeah, LiDAR on our personal devices, that is good, ubiquitous. And you look at the number of sensors that are on the new Apple Vision Pro headset, it's their
Mm.
augmented reality headset. That is an amazing piece of engineering. I mean, it costs as much as some of the equipment that you're using, but in terms of giving that now to not the professional, but to the consumer, and being able to have consumer grade usable software as well, right? So not sitting down with a seat of AutoCAD, but having something that is much more accessible to the consumer audience. again, probably cloud connected, right? By way of an app. So we're used to making a lot of desktop applications, but I am curious to see what happens when it comes to processing and being able to take this data and display it and use it in an app.
Great point. Yeah, the consumable side of this, if everyone can capture it, right, everyone's got to be able to consume it. So yeah, great point. Couldn't agree more.
Great. Well, if people want to learn more, this has been great, Pete. Where can we point them when it comes to the work that you're doing?
Probably my website, VCTOLabs.com, just like it sounds.
Great. Well, any closing remarks? Anything you want to get in there before we finish up today?
I can't think of one other than thank you both so much. And remember the inverted triangle.
Great. Yeah, well, thank you so much. It's been great talking with you. Great conversation. Really did enjoy this today.
Thank you both.
And thank you, Pete. And I still maintain you have the coolest job on the planet. And I think this conversation just reiterates that. So thank you so much. And thank you to our listeners who joined us for this episode. If you liked what you heard, please share it with colleagues and coworkers or anyone else you think would be interested. Please subscribe to our podcast on SoundCloud or iTunes or wherever you listen to your podcast, and leave us a review on iTunes or Spotify, or again, wherever you listen to your podcast. So these conversations are more discoverable by those in the industry who are interested in these topics. So thanks again to both of you. Thanks to our listeners. And until next time.
Thank you for joining us on the Beyond 3D podcast, hosted by TechSoft 3D. Be sure to subscribe on iTunes and leave us a review, or subscribe on SoundCloud. To listen to past episodes or learn more about TechSoft 3D, visit www.techsoft3d.com/blog. Send us comments and suggestions at info@techsoft3d.com. Thanks again for listening, and we hope you'll join us again on the next episode of Beyond 3D.